guys, welcome back to the channel. Today we have brought another problem of strength of material shown on circular bar. Last one we have done, we have in the same manner. The last problem of the numerical, we have find out the stress in a particular segment. But in this problem, which is the same kind of problem, bar with its uniform cross section, circular cross section, but we will try to find out the elongation this time. Means total change in the length. Okay, so as usual, you have to balance the forces in each of the segment. Okay, that is the KL, LM, and the MN. Okay, so it has been given the area of cross section and also the length, particular length 500, 800 mm, and 400 mm. All right. Okay, so in the KL, if you see, okay, KL see in the left hand side it is 100 Newton. So let me put here like that. 100 Newton. Did you follow? Yes. So to balance it, we have to use a similar kind of, that is a tensile kind of force, that is 100 Newton here. So it is obviously tensile in nature. So this segment of the bar is under stretch. Okay. Okay. So in the second segment, see, if you can see, we have used in this one, we have used 100 Newton. Is it not? In the right hand side. Okay. See. But in here, it is 250 Newton. Okay. Do you follow? See, this is the 250 Newton in the second, that is the middle segment. So out of 250, we have just used the 100. Okay. So what we need to do now, see, out of 250, we have used only 100. So it is 150 is left in this direction from left to right. So we are applying this left to right, say 150 Newton. So similar kind of pushing force, that is the compressive force, has to be applied of 150 Newton to balance it. So it is compressive in nature. Are you following me? Now see, 150, and out of 150, now you can see in here, this is 200. Okay, 200 towards the left direction, from right to left. Okay, so that 200 Newton, out of 200 we have used how much? 150. See, we have used 150. So 200 minus 150, it is 50 Newton. So if you see, the force has to be balanced and equalized. It is already been given as 50 Newton. So in this direction, it will be 50 Newton. So seeing it, you can easily say it is tensile in nature. So we have resolved the forces or balanced the forces in each of the segment, where the first segment, that is the KL, is tensile and LM is compressive and MN is the again tensile. So total elongation. So total elongation is equal to, that is del L is equal to del L1, means the elongation in the first segment plus elongation in the second segment, del L2, then del L3, elongation in the third segment. Okay. So in the first segment, that is the KL, this is nothing but KL segment. This is nothing but LM segment, and this is nothing but MN segment. Okay, don't get confused. 1, 2, 3 represent the first, second, third from the left hand side. Okay, so your formula stands in this way. Del L, that is the change in length, can be written as P1 L1 PL by AE, right? So they have different forces, different length, but they have a uniform cross section. So A will be simply as A, not A1 or A2 or A3, and they are made of the same material, so into E. Next, it will be also for the second segment P2 L2 into AE, and it will be next P3 L3 and AE. You might be thinking, why I have used any operator like plus or minus? See, it will be plus in the third segment. In this segment, it is plus. Okay, but what happens? Since the second segment, that is the LM segment, is compressive in nature, we have to use the negative sign in here. Are you following me? Okay. So let me take the common part, that is 1 by AE is the common. So your formula goes like P1L1 minus P2L2 plus P3L3. Is it not? Okay. So let me put the values. E is given as 2 into, I guess, let me check. Yeah, let me check once again. What is the value? I think it's 200 GPa, most possibly. Yeah. For E, that is the Young's modulus is 200 GPa. That is for steel. The material is of steel. Okay. So let me put the values here. Uh, 25 into 200 GPa. That is, if you know, GPa is that is 200 GPa is 10 to the power 9 Newton per mm square. Okay, let me, yeah. So since it is on Pascal, so let me, it will be not mm square, just a minute, it will be m square. Okay, are you getting my point? See, it's 10 to the power 9 Newton per, means 200 GPa can be written as 200 into 10 to the power 9 Newton per mm square. So what will happen if we convert this meter square into mm square? It will be 6. Yeah. See, we have to resolve this to make you clear. Let me put this value later on and clear me this thing first. We'll come into this thing, putting the formula values in here later. See, your E is 200 into 10 to the power 9 Newton per meter square. G stands for giga, that is 10 to the power 9, and Pascal, Newton per meter square. So 200 into 10 to the power 9 Newton for mm square, 1 meter equal to how many mm? This is 10 to the power 3 mm. So it will be like that. Let me check and let me clear you this thing, because there should not be any doubt. See, Newton per mm square, so it is 10 to the power 6 mm square. Okay, why we are trying to get into mm square? Because your value, all the rest of the values are in mm, not in meter. Okay, so it will be like 2 into 10 to the power 11. I have taken this to 0 also, minus 6. So it is Newton per mm square. It can be directly written as 2 into 10 to the power 5, but I'm just showing you guys so that you feel at ease. Okay, okay. So your E value in Newton per mm square is this thing, 2 into 10 to the power 5 Newton per mm square. Okay, so what was your formula? Del L is equal to 1 into 25 into 2 into 10 to the power 5, and we have to put out the value of P1 L1. You can check the P1 L1. See, let me go back. P1 is 100 Newton, P2 is 150 Newton, and P3 is 50 Newton. So we'll put the values accordingly. And your L1 is this one. Your L2 is this two, 800. L1 is 500 and L3 is 400. All are in mm. Okay, please mind that. So we'll put into this formula now. Okay, so let me put, don't forget the negative sign. Okay, so it will be 100 into 500 minus 150 into 800, yeah, 800 mm it was given, plus P3L3 is 50 into 400. So P1L2 minus P2L2, P1L1 minus P2L2 plus P3L3. Okay, okay. So let me write it as 50 into 25 into 2 is 50 into 10 to the power 5 And let me check these values. This will be 5 4 zeros, and there will be 3 zeros already there. There will be another 0 plus 4. It is 1 2 4 zeros. So 5 4s are 20, and then 3 zeros. Okay, I'm doing it as easy as possible, as slow as possible. Otherwise, the video will be very longer for this one problem. So 50 into 10 to the power 5. So it will be like 50, yeah, 55. It will be minus 50,000, I guess. Let me check again. Yes, 70,000 minus 1. Yeah, it will be minus 1,20,000. It will be minus 50,000. Okay. So 50, 0, 0. I have used the comma to so that the zeros are being counted. Otherwise, you might be making something wrong with the zeros. Okay. So let me do this. 5 1000, right? So it will be like minus 1000 into 10 to the power minus 5. So please mind that since all are in mm, it is in mm. So your value is minus 10 cube minus 5 mm. So it is nothing but minus 10 to the power minus 2 mm. Okay, so your del L is equal to minus 1 by 100 mm. So you can write it as, therefore, del L is equal to minus 0.01 mm. Okay, I hope you have got the point. That is, the total elongation is coming in negative, means that there is no elongation actually, there is a change in length. So the body in total has been compressed because the value is in negative. So the negative sign indicates that the total elongation is in the negative side, means the body has been compressed. Okay, so I hope you have got the point. So it is 10 to the power 5. Let me check again the values. Yeah, 0 0 gone, 1000, 10 to the power 3, 10 to the power minus 2, then it is 1 by 100. Yeah, it is right, I guess. Yeah, so you can check the calculation again, but I hope you have got the point of finding the total elongation or change in the length. And we will come up with another problem of SOM within few days, or maybe tomorrow or day after tomorrow, and we'll be discussing. Kindly pause the video in between if you want, because that's how you can take notes, and you can no again repeat the video in anywhere you like, or you can give me any comment if you want to ask me something regarding this problem. Kindly do subscribe. So if you subscribe, this will motivate me. Thank you so much. Kindly take care. Bye bye.